Assalamualaikum to Puan Nur Azimah. My name is Muhammad Haris bin Abdul Khair. My group members consist of Ahmad Fakih bin Azhar, Syarul Nizam bin Yaakob, and Muhammad Johan Iskandar bin Abdul Razak. So today we will present about vector and scalar in a plane. First, scalar and vector. This topic explains the basic operation of vector and scalar quantities, including their use in solving problems. The topic also explains the method for determining the angle between two vectors as well as the characteristic of triple vector and scalar product. Vectors are typically illustrated by drawing an arrow above the symbol. The arrow is used to convey direction and magnitude. Example as the picture. So I pass to Ahmad Fakir to continue.
Okay, thank you for Haris for giving me. Okay, the length of the vector is drawn to scale and shows the magnitude of the vector quantity. The direction of a vector is the counterclockwise angle of rotation which that vector makes with due east or x-axis, as the picture given. Next is example of vector. Example of a vector velocity of a plane. A velocity is sometimes the result of combining two or more velocities. A small plane is heading south at speed of 200 km per hour. If there was no one, plane's velocity would be 200 km per hour south, as the example. Next, first, the plane encounters a tailwind of 80 km per hour. Resulting velocity relative to the ground is 280 km per hour. 2 is its axis. The wind changes direction suddenly 1,800. Velocity vectors are now in opposite direction. Flying against a 80 km per hour wind, the plane travels only 120 km in 1 hour relative to the ground, as the picture given. Okay, I pass to my member to continue this.
Okay, thank you to Muhammad Haris and Ahmad Fakir. After this, I will continue to present this chapter. How to find resulting velocity of the plane in the case of tailwind and headwind. In 1 hour, plane will move 80 km east and 200 km south. So, it will cover more distance in 1 hour than if it was moving south only at 200 km per hour. To find that out, we have to add these two vectors. The magnitudes of resultant velocity can be found using Pythagorean theorem. Okay, from this we can see the example of calculation. Okay, next. Okay, for multiplying vector by a scalar. Multiplying a vector by a scalar will only change its magnitude. Multiplying vector by 2 increase its magnitude by a factor 2, but does not change its direction. One exception, multiplying a vector by -1 does not change the magnitude, but it does reverse its direction. Okay. For the vector addition head-to-tail method, we will know that vectors are drawn to scale in given direction. The second vector is tail is positioned at the head of the first vector. The sum of two such vectors is the third vector, which stretches from the tail of the first vector to the head of the second vector. Okay, after this I will to leave for Johan Iskandar to continue.
Thank you for giving me chances to talk. Okay, let's continue about components of vector. Any component can be resolved into two component vector.
These two vectors are called component. As you can see in the slideshow, there's two diagrams that show the components. For example, a plane moves with velocity of 34 meter per second at 40 degree. Calculate the plane's horizontal and vertical velocity components. The plane moves velocity of 34 meter per second, 48 degree. It's heading north, but the wind is blowing east. Find the speeds of both plane and wind. As you can see the calculation in the slideshow, find Vx and Vy. Okay, for the conclusion, what can we conclude is this topic has a function in our daily life. Therefore, we should be able to master this topic because it has been widely used in various fields. I think that's all from us. Move to Haris.
Okay, I think that's all from us, and thank you.